Good day, everyone. Today I'm going to discuss the
What is relativistic energy? Relativistic energy refers to the energy associated with an object that is moving at a significant fraction of the speed of light. Um, it is a concept of derived from Einstein theory of relativity, which revolutionized our understanding of space, time, and motion. According to special relativity, the energy of an object is not solely determined by its mass, but also by its velocity. The relativistic energy of an object can be calculated using the Peacemus equation, which is E is equals to mc squared over the square root of c1 b squared over c squared. In this equation, E represents the relativistic energy, m is the rest mass of an object, c is the speed of light in a vacuum, b is the velocity of an object, and square root of 1 minus b squared over c squared is a fraction known as the Lorentz factor. As an object approaches the speed of light in relativistic energy increases significantly. This is because the Lorentz factor approach infinity as the velocity approaches the speed of light. Consequently, it would require a infinite amount of energy to accelerate an object with mass to the speed of light. Relativistic energy is the fundamental concept of understanding the behavior of particles at high speed, and it is crucial in fields such as particles physics and astrophysics. It helps to explain the phenomena like dilatation, length, contraction, and equivalent of mass and energy. And now,
relationship between relativistic energy and integral and derivatives, and provide you some example and formula to better understand this connection. In mathematics, the integral and derivatives play a crucial role in analyzing the behavior of function. Surprisingly, these mathematical concepts also have connection to relativistic energy. So let's start first with derivatives. The derivatives of function represent its rate of change at a specific point. In the context of relativistic energy, the derivative can be used to calculate the rate at which an object energy change as its velocity varies. For example of this one is, let's consider the particle with relativistic energy function E that depends on its velocity b. By taking the derivative of this function with respect to velocity denoted as dE over dB, we can determine how the energy change as the velocity change. The derivatives provide insight into the behavior of particles and its energy at different speed. So another example is, let's consider the particle with a relativistic energy function E is equals to m0 c squared over square root of 1 minus b squared over c squared, where MO or M0 represent the rest mass of the particle, C is the speed of light, and B is the velocity of the particle, and the square denotes squaring by taking the derivative of the function with respect to the velocity, denoted as dE over dB. We can determine how the energy change as the velocity change. Now let's move on to integrals. In integral, they are used to calculate the total accumulation of an quantity over a given interval. In the case of relativistic energy, integral can be employed to determine the total energy of the object by integrating its energy function over the range of velocities. The example for this one's suppose we have a particle with relativistic energy function E that describe its energy at different velocities. By integrating this function over the specific velocity range denoted as, we can find the total energy of particle within the interval. And the other example of integral is, let's say we have the particle with a relativistic energy function E is equals to m0 c squared over the square root of 1 minus b squared over c squared. We can use an integral to find the total number or total energy of the particle within the specific velocity range denoted as the integral of e dv. Now let's consider a word problem. For example, suppose we have a spaceship at rest mass of 1000 kilogram. The spaceship is traveling at a velocity of 0.8 seconds, where c is the speed of light. We want to calculate the relativistic energy of the spaceship using the formula E is equals to MOC squared over square root of 1 minus B squared over C squared. So to find the relativistic energy, we substitute the values into the formula. So E is equals to 1000 kilogram, 3 times 10 the power of 8 meter per second squared over the square root of 1 minus 0.8 c squared. After evaluating the expression, we can find the relativistic energy of the spaceship. In summary, derivatives and integrals. To summarize the derivatives and integral, which are the fundamental concept in calculus, we can apply the relativistic energy to summarize derivative and integrals, which are fundamental concept in calculus. We can be applied relativistic energy. Derivatives help us to understand how energy change with respect to velocities, while in integral it allows us to calculate the total energy of an object over a given velocity change. The in formulatic terms, the derivative of relativistic energy function E with respect to velocity is given by dE over dV. And in integral of the relativistic energy function E with respect of velocity v over a specific range is denoted as this one. So that's all my discussion, and thank you so much.